82 lifted off from this launch pad. The reusable space shuttle system transformed the way we operate in space. The space shuttle launched dozens of communication satellites, as well as robotic spacecraft on groundbreaking missions to Venus, Jupiter, and Saturn. Not only did the shuttle deploy the Hubble Space Telescope in 1990, but it conducted 5 repair and upgrade missions that enabled the Hubble to literally rewrite astronomy textbooks. The Space Shuttle program ultimately assured its place in history with the complex on-orbit assembly of the International Space Station, the ISS. The shuttle made 37 flights to construct the station, which is larger than an American football field and can be seen at night orbiting Earth with the naked eye. This unique scientific platform allows researchers from all over the world to work on innovative experiments and help to enable NASA's long-term human exploration plans.
All right, folks, out in front of the bus is that second crawler we talked about. On top is a mobile launch platform that came off of 39A. It's the same platform that the Atlantis launched off of on July 8th of 2011 to become the last shuttle launch. The crawler up underneath weighs a mere 6 million pounds. Goes 1 mile an hour loaded, speeds right on up to almost 2 miles an hour unloaded. That's how we get the rocket assemblies from the VAB out to 39A and 39B via the crawlway. The crawlers were actually built by Marion Power and Shovel Companies in Ohio, shipped to Florida in the early 1960s in pieces, and then and then they were assembled down here at Kennedy Space Center. This one's for sale, guys. If you have your checkbook, you might be able to swing a deal. Next video tells us about the future of 39A, which is out in front of the bus now.
Since the end of the Space Shuttle program in 2011, Pad 39A has begun yet another transformation. Commercial developer SpaceX is modifying the pad to launch a larger version of their Falcon 9 rocket called the Falcon Heavy. SpaceX is also building a crew capsule capable of carrying astronauts and will be launching crews to the International Space Station as part of NASA's Commercial Crew Program. Another commercial provider to support NASA's crew transportation is Boeing. They named their capsule the CST-100. Like SpaceX, Boeing's capsule will begin flying to the station later this decade. They will launch from Cape Canaveral Air Force Station just a few miles from here on a modified Atlas V rocket. With private industry stepping up to support low Earth orbit missions to the ISS, NASA can focus more heavily on deep space exploration, which you will learn about at Launchpad 39B.
39A, folks, the most historic launch pad in the world. SpaceX has a 20-year lease on this for that commercial crew program, so they can use their Falcon Heavy rocket with the Dragon crew capsule and take our astronauts to the space station. On top of the pad, that white piece of horizontal equipment is called a transporter. That will come down here inside of the building, called an HIM. They will horizontally assemble the Falcon Heavy on top of the transporter, then take it up to the top of the launch pad, raise it up vertical, and get it ready for launch. The Falcon Heavy is actually 3 Falcon 9s hooked together. A Falcon 9 has 9 rocket engines. A Falcon Heavy is going to have 27 engines, folks. It's going to be at least as powerful as the shuttle. Now, if you notice the launch pad goes up at an angle. That's a 5-degree angle. They do that to build the flame trench into the elevated launch pad. To the right, the big water tower holds 320,000 gallons of water. 16 seconds before ignition, they dump that water right into the flame trench. They do that to help suppress the noise. If they wouldn't do that, the vibration from the sound waves would damage the launch pad, possibly the launch vehicle. It could stop your heart, and yes, sir, we break windows 20 miles away. SpaceX is going to use the center part of the shuttle tower with the 80-foot tall lightning rod on top. The rotating service structure sticking out to the left, they're not going to use it, folks. They're going to dismantle that. The big round white tank over here to the left front holds 800,000 gallons of liquid hydrogen at minus 423 degrees. There's another tank like it on the other side that holds 750,000 gallons of liquid oxygen at minus 295 degrees. Those are the two fuels that propelled the shuttle from 0 to 17,500 miles an hour in 8 minutes. That's how fast you must go to get into and stay into low Earth orbit. The space station is only 250 miles above us, and it orbits the Earth